I'm like, all right, that's cool. He came out like a posse, holding up like a UFC belt, skipping out onto the mat.
Can't have that going on. Yeah. Huh.
When we were at the airport, they like sat there, they're like wrestlers in the away section at ours, and they were talking crazy to us.
Oh, all right, so we'll get rolling and that way we can get out of here maybe a little early. Should be able to. Unfortunately, I forgot to hit record with my last class because I was like, God, this class will get early and short. And so I got to record these problems so I can put it on as you learn the new problem or for the new book. Hopefully everybody got my email about the quiz and smart book dates when they're due. So that'll be due Tuesday for chapter 8. Okay, make sure you pay attention to the times on those because the quiz for each class is different than an hour before your class. And the smart book, and then the video questions will be due like March 5th, I think it is. They'll be due before the exam. So I'll basically just make sure you're on top of those assignments, okay? So we'll start chapter 8 Tuesday. It's a short chapter. We'll knock it all out in one day. I'll just tell you guys up front. You're gonna read the chapter and you're gonna be like, oh, wow, what's going on? Don't stress, okay? When you come in Tuesday and we go over it, when we're done, you'll be like, wow, is that simple? It is that simple. Chapter stocks are very simple. They aren't very complicated at all. Yeah. So just be prepared for that. Any questions on any of that? Okay. All right. So let's knock these problems out. And we'll go through these and make sure everybody's good to go with those. And then call it a day and go enjoy our weekend. Okay. So we're doing 3. So on problem 3 here, even though most corporate bonds in the U.S. make coupon payments semi-annually, bonds issued elsewhere often have annual coupon. So we got a German bond with a par value of €1,000, 19 years to maturity, a coupon rate of 3.6, and a yield to maturity of 3.2. So what's the current price of the bond in euros? What type of bond is that? Has a coupon rate of 3.6 and a yield of 3.2. Premium bond. Yeah. Okay. So let's put this on the timeline. Okay. We've got 19 years to maturity, coupon rate of 3.6, a yield of 3.2, €1,000 bond, annual payments. So what's our annual coupon on this? Or what's our coupon on this bond? $36, right? Okay, we said it's a premium bond, so we know what does that mean for the price? Higher than the par value.
Because it's semi-annual, 36.5.
It's not similar. Read it. If you go back and look at the problem, it says most bonds in the U.S. make semi-annual. Elsewhere, they're annual.
Oh.
So it's telling you it's an annual. Okay. So we're gonna first thing we need to clear the calculator. Okay. And then we need to check our periods per year, right? So 1 period, because this is an annual bond. Okay. And then we just put the information in 19 periods. We got a 3.2 yield, 36 payment, and $1,000 face value. So the price, $1,056.29, right? Everybody good on that? Questions on that one? All right, pretty straightforward, all right? So let's look at the next one. Number 4, so Japanese company has a bond outstanding that sells for 104.352% of its 100,000 yen par value, premium or discount bond? Premium bond, how do you know? Bonds are quoted as what? Percent of par value, right? So this is 104%, means it's a premium bond, okay? Bond has a coupon rate of 3.4 and it matures in 16 years. So we're looking for the yield to maturity on this. So what do we know about the yield to maturity on this bond? Lower than coupon. There you go, you're 2 for 2. All right. So we got 100,000 yen, right? Coupon rate of 3.4. It's an annual bond, so what's our payment? 3,400. Okay. We've got was it 16 years to maturity? Yeah, 16 years to maturity. Okay. And it's selling for 104,352 yen, right? So what is the yield? Okay. So 16 years. 104,352 negative is the present value. 3,400 is the payment and the 1,000. And you just compute the yield. That's it. And this one, what I miss?
1,700. So you're free for something.
Oh, I left I put it way short. I did 1,000 instead of 100,000. There we go. 3.05, yeah. I was like, something's definitely wrong on it. 3.05, okay? Everybody good there? All right. Let's look at 5. So has a bond on the market making annual payments, 8 years to maturity, par value is 1,000, selling at 962. So that obviously is a discount bond. Bond yields 5.7. So we're looking for the coupon rate here. So we've got 8 years, 1,000. 5.7 selling for 962. It's an annual bond. So when we solve for this, we're actually solving for what first? The payment. Okay. So what do you get for the payment? Okay. So the payment is 50.95. Now that's the payment, but we're looking for the coupon rate. So how are we going to get the coupon rate? Yeah, take the 50.95 divided by 1,000. So our coupon rate is 5.095%. Everybody good? All right. So 6. So 6, you got the company issued 15-year bonds a year ago, coupon of 5.4, semi-annual payments, okay, par value of 1,000, a yield of 6.1. So this bond is what? Got a yield of 6 and a coupon rate of 5. Discount. This one's a discount bond. Okay. So here, now remember, this is semi-annual. Okay. So 1,000. Now it was a 15-year bond issued a year ago. So N is 14. Okay. And let's see, we got a 6.1, the coupon rate is 5.4. So what's our payment on that? Huh?
54 by
54 divided by 2, so 27. Okay, is everybody good with that? Everybody realize where that comes from? Okay. All right. So we already cleared it. We got to check. Oh, this is semi-annual, so make sure we change our periods. Okay. 14 years times our 2 periods. That's where we get our 28 from. 6.1 is the yield. 27 is the payment, 1,000. Okay, compute present value, 934.73. Everybody good?
Okay,
What'd you get?
960.
Did you multiply your years by your periods? Yeah. 14 years, it's semi-annual. And did you use 14 or 15?
And I put 2 as the
2 periods per year? Yeah. Now, did you so when you did that, right? Now, did you do 14 times your periods per year? And do it again?
why do you have to do that? Because it's semi-annual?
Yeah. Yep, semi.
So like, if it's any problem with semi-annual, if I just multiply the periods by 2, that would give me the same thing.
Well, you can't do that. Because, see, if you don't. Remember, when we do when we put the periods per year in, okay, and put the periods per year in here, what is the calculator doing for us with our yield maturity? Or the interest rate? It's dividing it, it's putting it into a periodic rate, right? Semi-annual. And so it's taking that interest rate, dividing it, putting it in the periodic rate, and it's also taking our periods and multiplying it by years. If you do not do that, if you don't put the periods per year in there and then multiply it, the calculator won't do it. Okay. So, and that's why it gets important. And if I remember, there's another problem that deals with that, and I'll show you that one. I'll bring it back up then, and you'll see why it's important.
So every semi-annual problem, you have to do that.
Anything that's not 1. If your periods per year is greater than 1, you have to do the second. Yeah. Yep. Okay. All right, so let's look at 7 here. So it has 25-year bonds issued 2 years ago, coupon rate of 5.6, semi-annual payments, currently sells for 92%. Now notice, this doesn't give you a face value of par value. So you can put anything you wanted. You can put 100, you can put 1,000, 10,000, 100,000. I usually use 1,000 because most of the time it's easy to do the math in your head as to what's the coupon and things like that, right? So whatever we put here, if I put 1,000 here, it's selling at 92% of whatever that face value is. So that means the price is $920. Okay, again, it's a semi-annual bond. We have 23 years to maturity. Okay. Coupon rate is 5.6%. So what's that make the coupon? Yeah, so 28, and we're looking for the yield there. Now, since this is a discount bond, what do we know about the yield maturity? It's higher than the coupon rate. So when you solve for the yield on there, what do you get? 6.26. Okay, now, so Amelia, going back to your question and what you did in the last problem, right? If you would, if you don't put the periods per year in it, right? And you wanted to, so if you left the periods per year here at 1, and like you multiplied the 23 and put in 46, your answer would have been 3.23. Because, and that's the periodic rate, but then you'd have to multiply it. That's why I teach you guys how to put the periods in there. Let the calculator do all the work for you. Why do you want to have to think, man, did I divide the interest rate? Did I multiply the periods? Do I have to multiply the interest rate when I get my answer? The calculator will do all that for you if you put the information in the way I told you. So I like to let the calculator do all that to think about. Do I have to multiply, divide that? Do I multiply this number, divide that number? Did I put it in? Did I not put it in? What do I do? And that's why I don't think any of you guys are using them, but the 83, 84, because it does some of that and doesn't do the other part and all that. So I just think it's easier if you do it that way and let the calculator do all your stuff. We've got tools, let's use them. Okay. Is everybody good? Okay, let's look at 8. So number 8 here, now you have 14.5-year maturity on these bonds, a yield to maturity of 5.3, $1,000 par value, current price is 1037. Okay, now look, the price and the par value are very close. This is a premium bond, right? And we have the, we have the yield to maturity. We're looking for the coupon rate. Since it is a premium bond and the price and the yield are close, what do we know about the coupon rate and the yield to maturity? The coupon rate is going to be higher than the yield, but since the price and the par value aren't very far apart, the coupon and the yield are going to be pretty close too. Okay. So that, again, that's why I like bonds, because they pretty much help you out and give you an idea of if you're in the right direction. Okay. So we got semi-annual, 14.5, 1,000 here, 1037 here, 5.3. Okay. And we're looking for what here? Payment. Okay. And what do you get for the payment? Okay, we got a few different answers, so let's take a look. Okay, so let's see. Periods per year, right? We got that in, so we got to do 14.5 times our periods per year. Okay. Our yield to maturity is 5.3. 1037 negative is our present value, and 1,000, whoops, 1 too many, is our future value. So I'm computing payment. 2834. Okay. All right. Yeah. No, see that's what I was we're getting ready to talk about. So that payment, now remember, we said the payment of what goes into your account, right? So that's just, so you're getting 2 of those payments. So to find out what it is for the year, what do we have to do then? We got to take this and multiply it by 2. So that is 8,656. Okay, so that is our coupon payment for the year. We're still looking for the coupon rate. So what do we have to do? Take that, divide by 1,000. So the coupon rate is 5.668%. Does that make sense, Paul? Okay. So, and that again is where, if you put 1 in there, you got to remember to do all this other stuff. above what we would say.
Yeah, I put in the 1,000 for the present value section. I got it.
Good. All right. Let's see, so that's semi-annual, 10 and 11. We'll do, let's 9, 10, and 11 are similar. We'll do one of them just because we don't have a $1,000 par value. Let's jump to 10. Okay. So when we jump down to 10, Yan Corp has a $2,000 par value bond outstanding with a 5.5% coupon rate paid semi-annually, 13 years to maturity, a yield to maturity of 5.8. Okay. What's the price of the bond? So we have a yield of 5.8 and a coupon of 5.5. So we have a discount bond, right? Okay, so when we put this on here, it's 2,000 here. Again, it is a semi-annual bond, 13 years to maturity, 5.8, coupon rate of 5.5. So what's our coupon here? 55. Yeah. So you got to take the 2,000 times 0.055. Give you 110 divided by 2, 55, right? Okay. And then we just got to look for the price. So I know it's already semi-annual. I don't have to worry about that. I can just go 13 years times my periods, 5.8 for the yield of maturity. 55 is a payment, 2,000, and then compute present value. So 1945, 75. Everybody good there? Okay. Okay, there you go. Everybody good? Questions? Okay, let's jump to 12, 13, and 14. We're dealing with the Fisher effect. Now the Fisher effect, if you remember, we're talking about nominal rates, real rates, inflation rates. So we'll solve for each of those, okay? So treasury bills are currently paying 4.9%. That 4.9, what rate is that, or what is it? That is the nominal rate. That is capital R, okay? It says inflation is running 3.1. What is the approximate real rate? And what is the exact rate? Okay, so here we're looking for R. You got that, and you got this. So this says this is 4.9 running 3.1. Is that right? No, inflation was 3.1. I'm sorry. Let me erase that. Inflation was 3.1. So we can subtract inflation out of there and say approximate real rate of return is 1.8, right? Now we're dealing with Fisher effect. So 1 plus the nominal rate equals 1 plus the real rate times 1 plus inflation. So we're looking for little r. So R equals nominal divided by inflation minus 1. So 1.9 over 1.031 minus 1. And what's the real rate here? $1.75. Okay. Now that might, you're like, why does that 500ths make a difference? Well, if you're dealing with maybe $100 or $1,000, it doesn't. But if you're dealing with $1 million, 10 million, or even $1 billion, that would make a huge difference in the answer, right? So that's why it's important. And I'm telling you folks, when you get out, I had an intern that was with one of the banks out in Utah, And she was in their audit department, and she said, if we got within $5 million, we didn't even look for any difference. We just looked for one. Okay, now, I'm sure they had another department that was probably in charge of going and finding that 5 million. But think about that. I mean, so the bank was like, okay, you're close enough, we'll call it that. So I'm sure there's another department that had to go find that. I mean, so when you're talking numbers like that the bank's like 5 million, man, okay, go on to lunch. We'll worry about that later. That's the kind of money that hopefully you guys will be talking about in your careers and stuff. Or better yet, if you do what we talked about with time value money and what we talked about with stocks and bonds and investing, I hope you guys will be in that situation. Maybe not $5 million, but you might be like, I'm not gonna go look for 500 in my checking account if it's close enough. Hopefully you'll have enough zeros in your account to do that. Yeah. All right, look at 13. Real rate is 1.8, inflation's running 6.4. What would we expect to see as a nominal? Okay. So here we're looking for that real rate inflation. We said this was 1.8 and this is 6.4. So put the equation there. Okay. So the real rate equals, just move the 1 to the other side. Okay. So 1.018 times 1.064 minus 1. So what's our nominal rate there? Okay, is everybody good on that? Okay. All right, let's knock out the last one. Last one's dealing with inflation. So total return is 11.7, so that's going to be capital R. Powell is the current chair of the Fed. He thinks the real return is going to be 6. So what's inflation? So nominal is 11.7. The real rate is going to be 6. We're looking for inflation there. So 1.117 over 1.06 minus 1. What's inflation on? Yeah, 5.3. Okay. Everybody good on those? That's all there is on Fisher effect. So if you know those 3 things, you'll be good on them. Okay. Everybody good? All right. Let's just jump to 19 and 20. 19, now what these 2 problems are dealing with, if you remember this is the main concepts with interest rate risk. What did we say interest rate risk was? You remember? The longer the period of maturity, the greater the interest rate risk, and the lower the coupon rate, the greater the interest rate risk. So that's what these 2 problems are dealing with. When we look at them, we've got basically 2 bonds. One bond had, let's see, both these bonds have 6.7 coupon rates. Semi-annual payments are priced at par value. So when it says it's priced at par value, what does that mean? 1,000. So is it a premium or a discount bond? Neither. So what does that mean? Because it doesn't tell you about the yield to maturity. But what do we know about the yield to maturity if they're priced at par value? Same as a coupon. That's why that's important. That's why that part's important. Okay. And one has 3 years to maturity, one has 20 years to maturity. Okay. And then it says what happens to it if interest rates rise or fall. So let's look at the first one. We got 3 years to maturity, 6.7. It's priced here, priced at par. So that means the coupon rate is 6.7. So what does that mean for the payment? Semi-annual. 33 something. Yeah. You're right, 33.5, right, half an hour, okay? So then it says, what happens to the price of the bond if interest rates suddenly fall 2%? Okay, so 3,000, you know, this is 33.5, and this is 4.7. What's the price of the bond? It's gonna be a premium bond, so it'll be higher. So what's the price of the bond? There you go. And actually, the question asks you, what's the percent change in the price? You guys know how to calculate percent change, right? Ending minus beginning divided by beginning. So 55.36 divided by 1,000, that's a 5.536% change in the price.
How'd you get 1,500, 55?
How'd I get the price?
Yeah.
Okay, so they cleared everything out, right? Then I gotta check this semi-annual, so that's there. This is a 3-year bond, so 3 years, whoops. Crap. What, 3 years times my periods per year is 6, right? Okay. 4.7 is the yield to maturity. 33.50 is the payment, and 1,000 future, that is computer price.
I was trying to complicate it. I was thinking like, oh, you multiply it by how much 2% is, then add that back.
Yeah,
So 5.536, would you do that?
okay, so you take the difference, okay? Let's do this. So when you're looking at percent change, it's ending minus beginning divided by beginning, right? So it's 1,055.36 minus 1,000 divided by 1,000. So 55.36 divided by 1,000. All right, then it says, well, what if interest rates rose by 2%? So same thing here, this is the same, this and this. But now this is 8.7. Now what do we have? No. Now you have a discount bond, right? Now, all you have to do, everything else it's the same in the calculator, just change the interest rate. 8.7 is the yield and compute present value. 948.17, right? So 948.17. So this is a 51.83 change. So that means the price went down 5.183. Okay. Everybody good on that one? Okay. Now it pretty much says, okay, let's do the same thing, but instead of a 3-year bond or 3 years to maturity, it's 20 years. And let's see what happens. Okay. So we got this. This is going to be 20,000. This is going to be 6.7. This is going to be 1,000. 33.5. Okay. So that doesn't change. But what happens if this changes to 4.7? And what's the price of the bond now? $12.57.49. So the percent change there is 25.749. Okay, is everybody good on that? Okay. And then it's sorry. The same thing, what if it goes up? So now we got 8.7. What's the price of that one? There you go. 811.98. Okay, if we calculate that price, it's 18.8. Okay. So, couple of things here. One, you can see the change, okay? Anybody notice anything else there? About the change? Yeah, that's the main concept. Okay, so we can see, hey, the change goes from 5% to 25 and 20%, 19%, right? The other thing I want you to notice too, look at the difference in the change when it's positive and when it's negative. What do you notice there? Yeah, so the price change, if it's going against us, it's not gonna, the price isn't gonna change as much if it's going against. Now, if it's going for us, being beneficial to us, the price change is gonna be a little bit bigger. So that's kind of an interesting quirk on bond. Hey, if the price change is gonna be beneficial to us, that's gonna be a bigger price change than if it's gonna be detrimental to us. Okay. Everybody good? All right, so that was time. So let's see what happens to interest rate or coupon rate. Okay, so here we're gonna look at 20, and it's gonna be the same thing. A little different though. We got two different bonds. One has a 3% coupon rate, one has a 9% coupon rate, 18 years to maturity, 7% yield. Okay, so we've got 18 years, 7%, semi-annual. This is 1,000. Coupon rate of 3, so that's 15. So we have to calculate our starting point. What's our starting point? What's the price of this bond? What do you have?
594.
Carly? No. Haley?
Haley.
Haley. Oh. I knew that wasn't right. That's why I was like, Haley. One more time, 594.
The 19.
19 cents. Thank you. Okay, now it just says same thing, right? What happens if it goes down 2%? So just change your interest rate. And what do you get? There you go, Nick. 764.44. Okay, that percent change is 28.65. It's not off 1,000, so I can't do that in my head. Actually, I figured I'd just get that. Okay, so then it's what happens if it goes up 2%. So now it's 9. And what's that price?
2 cents.
Yeah, 2 cents. Okay. So that one is down 20.9. Okay, is everybody good on that? So now they want to contrast that with a bond that has 18 and it's a coupon of 9. Okay, so 7. So what's our starting price on this bond? Well, that was bond J. Okay. What did you get there? It's almost, hang in there, it's almost over, right? Yeah. Not much longer. There you go. Okay. Then the same thing, they said, what happens if interest rates drop? So if this falls to 5%, what's your price?
1471.30.
There you go. Okay. And that is a 22.3% change. Now notice it says what happens if it climbs Okay. 9, what's that price gonna be? Oh, because that makes it a par value down, right? Okay, so in that case, the price fell 16.87%. Okay. So you can see now, contrast this to problem 19. You notice anything different? The effects have having a lower coupon are a little bit more, they sway more than time. So the lower coupon rate has a little more interest rate risk than the longer period of time. Is really what I want you to see. Okay. Everybody good? Questions on anything? All right. Go enjoy your frozen weekend as we get kicked some butt. I'm not sure if we'll make it, but we're gonna try to make it. We're gonna try.